Welcome back, class, and we'll continue with our series on graphics in R, and we are talking about quantitative data, so graphics for quantitative data. Remember, in the last video, we talked about histogram, stem and leaf, and box plot. Now, I am going to consider the case where you have a bivariate data, right? And then you want to get like a scatter plot, or what we mean, or a line plot, and so forth. So that's the next thing we'll talk about. So this will be the fourth. Okay, all right. Now, when we have bivariate data, and now the function to do or to get a plot of it is called plot. Okay. Now, usually, if you have even a single data, which is a vector, you can still do a scatter plot of it. What is going to happen is that I will just give it an index. So the first vector is assumed to be number 1, the next one number 2, and so forth. So you to name it up to the sample size, and that is your that becomes your x, and the actual vector you have now becomes your y. And I'll demonstrate this for you to see. Okay. So I first start with plot, and we look at the help files. Of course, we've seen plot, but we are now going to, treat it in detail. So plot, it means generic what? XY plotting. So you need X and you need your Y, but as I said, you can get Y may be optional, because if I have just X, I will push that to be Y, and then gives an index as X, where the index means just the arrangements, the position of it as X. Okay. So basically you need X and Y, but there are several arguments that you can also see. So one important argument is type. Now, so what type should be drawn? So for example, if we say P, then we need points. Okay, so we just get a scatter graph with points, then we need P. L is for lines, B is for both lines and plot, C line path, and so forth. So you can explore some of these things. I'm not just the first 2 or 3 are okay for our discussion. You have main. We've talked about main already, which is just a title, but you can also get a subtitle, right? So there's also sub. X lab, Y lab, we've seen it before. ASP is the aspect ratio, and so forth. This is not the end of it. Remember, I said there is a par, a function called par. We've used that in class to, for example, set the margins of our plotting area and so forth. So there are several arguments over there that you can put. And now we'll be talking about some of them as we move on. So, for example, plotting characters. When we want points, it's not just about points. We may want to get several of them. So I will start first with just a simple example. So this example, I am interested in plotting, let's say, the numbers 1 to 20. Okay, so by default, I can plot this. So I can say X is equal to this, right? Okay, and there, you see what is happening is that this X has now turned to Y, right? Okay, if you look at it over here, is Y. Okay, let me use par to set my margins. And this one, all of us have seen it before because I did it in class, but I'm going to do it again. It is used to set our margins. And you see the top ones, I gave it 1, 1, so it has closed the gap. And this is usually what you should do, because these ones occupy space for nothing. Okay, so usually you can close it, and your graph, fills the entire place for you, and that makes it better than when you don't use it. Okay. Now, so I want to see, for example, how many, the various colors I have. So I can color them. Each point I want to color it. And that means I'll give 1 to 20 as well. Let me run this and then see. So you see, it gives you the colors that you have in R. Remember, we have the rainbow colors. You can sample from it and so forth. One more thing is that there's also an argument called PCH. You did not see PCH in your plot, but as I said, that is part of the par. Okay, there are so many things that you can use par for. So if I go here and I want to see par, so it's just graphical parameters, right? So it sets what? Graphical parameters. So for example, the PCH that I want to do, I can look for it over here. You know, scroll down. All these are things that you can use to set your graph. So in R, the user has absolute control over your plot. That's why I was telling you in class that to teach you plotting alone will take us more than a year, because there are so many things, so many plots elsewhere that you can learn. And then also there's even what, a GG plot too, that I said some of you can explore. Those that are so interested, you can explore them. So look at it. The PCH that I want to use, it says what is either an integer specifying symbol or a single character to be used as a default in plotting points. You know, so there are additional, you know, arguments that you will not get in your plot, but when it is part of par, so you know you can use it in your plot command. Okay, so I want to see the first 20 plotting characters. So I have PCH is 1 to 20. And of course, everybody knows, or if you don't know, let me remind you, if you select 1 colon 20, what we mean is that the numbers 1 to 20. So I just selected that and ran it. And look at my console, I have 1, 2, 3 up to 20. So what we mean is I just plot the first 20 plotting characters in R. Also, the colors should be first 20 colors. So there it is. Okay, so you look at it. The first one is what? It's a circle. You have a triangle plus and so forth. So these are the various characters you can use in plotting, in plotting in R. Okay, so that's basically what you can plot is. Okay, so you see here, as I said, Y was optional. We did not provide any Y. So although I specified X as my values that I want to plot, I automatically gives it an index. Okay, and then it plots it. Okay, but let's get down to practice more. So we take a more practical data. So let's look at the data cars. Okay. Okay. So look at this. Cars, it says the speed and stopping distances of cars. The data gives the speed of cars and the distances taken to stop. Note that the data were recorded in the 1920s, so this is way back. Okay. So here, it has given its reference methods of correlation analysis. Very soon, when we start with this, we get to the descriptive aspect where we talk about the measures of central tendency, variation, and so forth. We will talk about correlation and so forth. So here we are only interested in just, you know, pictorial representations and the others. Okay. Now, so speed and then stopping distance. So here, if you want to analyze this data, you see your interest will be on the stopping distance, right? So if a car is traveling at 100 kilometers per hour, or 100 miles per hour, what is the minimum distance you need in order to stop so that you don't hit the next incoming class. So if I'm plotting this data, I'm going to make my stopping distance my y, or my dependent variable, or but that means I'm in the regression framework if I say dependent and independent. However, if it is just the correlation that I want to measure, then there's no need to specify one as dependent or an independent variable. They are all just variables. Okay, so let's see. All right. So we want to first get a plot of 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 the speed of cars. So let me give a comment like plot of distance versus speed of car. Okay. So this should be stopping distance, right? Stopping distance. Stopping distance versus speed of car. Okay. So we say plot X, I call my data cars, and then I want the speed. Okay, Y, I still call my data cars, and then distance. Okay, so this is a basic thing. Okay, if I plot this, there it is. Okay, but of course we want to what? Name it properly and so forth. So we can do xlab, slab, s label, and s label is our speed of car. Okay, and then y lab, we are interested in the stopping distance. Stopping distance. Okay. Of course, we don't need any mean, so we just there it is. Okay. So that's basically it. If you want to, for example, change the plotting character, you may want to say, okay, I want 2 or maybe 5. What is 5? Then we're going to change this, right? You see, it changes it. Okay. So that's about the plotting characters. Okay. There was type. Okay. Type, by default is P. But if I want L is also lines, so I can look at this. And you see the line overrides the plotting character. However, if I include, let's say, type is both, remember B is both, right? Then I need the character and I need what? The lines. So look at what will happen. You see, it joins them. So you have the plotting characters as well as what? The 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 the, the lines and so forth. So that's basically how you plot, okay, in R. Okay. All right. And this will be very important when we talk about regression. We will come back to this, and then we will superimpose lines on it and so forth. All right. Okay. Okay. Next, we look at let's say adding legends to plots. Remember in the assignment on the COVID, I did let you do all this because you were home and I wanted you to do some work. Okay, so I'm going to go through this again so that it will help you to now even better analyze the data I gave you on the COVID. Okay, outbreak. Okay, so now how do we add a legend to a graph? Okay, of course we use the function legend. So I want us to look at just generate some data. So let me say let me say I have x, and x is, let's say, sequence. Remember sequence, right? From -1 to 1 to 1 by maybe 0.01, right? So that's it. And yeah, so sorry, I don't need this. Let me take it to the other side. Um, okay, so I have x, and let's say I want a plot any function. Like, remember, we can um, x is equal to x, and then y is, let's assume that, let's say we want sine of x, right? Okay, so we can plot this. Okay. Um, yeah. So in order to, that's two. So let me just go back. This plot, I want it to be, get the sine curve itself. So let me say I can also start from -pi. Remember pi, our pi, as we know, pi in mathematics, is also, I also recognize it pi. Okay, so in this case, if I do it, you see, then you have your sine curve and so forth. Okay, so the idea here is that I want to plot sine, and then I want to plot, let's say, cos as well, and I'm using. So I'll go back and add some more. Okay. Um, so some more. Let me say I'll color this blue, or let me. Okay. So let me say blue. I'll color X lab. Maybe I'll just do X. Okay, this can come here because we still have some space, and then yeah, X lab is X. Now, because I will superimpose cos, this sign for cos as well. So I'm not going to um, name the y, because then it will be sine. But I want two things. So y lab, I'll say it is what? It is, let me put this recording back down. Okay. So y lab, I'll give it just nothing, right? Okay. So then I plot this. Okay. Let's say I can even say the line type. Okay. Type, I want it to be L. So L. Okay. So like that. And then if I do this, I have this thin line. Okay. There are so many arguments that you can pass to. So let me even add more. I can say line width. LWD is line width. You find this in pi as well. If I do it 2, it's going to make it a bit thicker. You see, this line is thicker. The larger the number, the more the more you increase the thickness of the line, and so forth. So there are so many arguments that you can pass on to it. But next one, I want to superimpose cos curve on it, right? So to do that, I'm not going to do plot again. If I use plot, it will give you a new plot. But what I'll use is lines. We've used lines before. So lines is just to, superimpose on any an existing plot. So if you don't have a plot, you cannot use lines, right? You first need line. And then what color do I want to give this? Color. Maybe color um, uh, blue, green, or maybe which color? I don't even know. Well, okay, so let's use maybe green. Okay, sort of, or black. We want black. Okay, so I can do this. Okay. Right now, you see, if I want to if I want the line weight to be the same, then I must also give this LWD, and then they look the same, and are the same thickness. Okay. But next, what I want to do is to be able to input in what? Um, a legend. Okay. Now, how do I add the legend? So here, I'll call for legend. Okay. Now, I want to put my legend somewhere here, the top left, so that I can say top left. Of course, you can use top right, or you can specify X and Y, and it will still do it for you. So, and my legend, so you legend within the legend, right, is what really you want to put over there. So first of all, I want sin X. So sorry, no, not this one. I want sin X. Oh, uh, what is happening? Sin X. And then, of course, the other one will be your cos X. Cos X. Okay. Then, so I can do this. Of course, color. I can provide a color. Um, you see, this is blue, so I copy blue, and then the other one is all black, right? I do it like that. Okay. Now, so now I can try this. So I get my sign and cos, but however, nothing shows that it is there, right? Or the color. So I'm missing a key um, argument called fill, and fill I can also give it the color. So I may even not bring the color. I can put fill. So if I put fill like this, then it gives it. So you can omit the color and use even fill. That should work. So this is how you add a legend to it. Remember, we use a color. I can also add the lines. Okay, so for example, I can line type. I didn't talk about line type, but you see, um, you can also use the line type that you are trying to do. So whether 1, 2, 3, and so forth, I can get broken lines and so forth. So if you use LTY like this, so I can go back and say LTY. So maybe this will be 1, which is solid line. Look at what will happen here. See, it's a solid line. And here I can say I want my LTY to be 2, and here I'm going to get a broken line. You get it? So the line type, we have several line types as well you can explore. So if I do this, I can also, use, then in my legend, I'm not going to say fill, but I'm going to use line type is equal to, let's say 1 and 2. Okay. So if I have this, then I'll be able to get my legend in terms of the lines as it is. And if I want it to be the width, sorry, the line width to be the same as that, I'm going to say line width, right? And what is my line width? They were all 2, 2. So I can say C2 and 2, C2 and 2, right? Which means it's a vector of 2 and 2. And you see now it changes, right? The legend changes to exactly the same line width as that. So that's how you input legends, and so for then you can have more of these in your um, R in action book. Okay. Okay. Next, we take a look at another plot called dot charts. Okay, so dot charts are also appropriate when, for example, you have two variables, so you want to still get line plot. However, let's say the x values are um, categorical, whereas your y values are um, numeric. So you want to plot it. In that case, plot doesn't help, but you can use dot charts, right? To do so. So, for example, in your COVID data, because you want to plot, let's say, the number of cases against the countries, you may use dot charts, right? And that will give it like plots and so forth. So let's see how to do that. You need a dot chart, and you can look at the help files of these dot charts and say labels, groups, how do you want to group it, and so for plotting character is 21, but you can change it to anything you want, and so forth. Okay, so let's look at a data set called plant growth. Okay, so plant growth is also in the data set package. It's a data frame consisting of 30 cases on 2 variables. If you want to display it, you can display it here at your console. So you see this, we can use it for our, it's just like our Norizia data, but here you have the weight and then group of the data. So the first one is the control group, then you have treatment 1 and then treatment 2. Okay, so what I want to do now is that I want to plot the weight according to the group. Do you get it? Now, so I can use dot chart to do this. There's another way to go about this, and that we call strip chart. So in that there are so many graphical output you can, but I'm not going to talk about all those things. I mentioned some of them. You can go on and do the help files and be able to read it. If you use straight chart will give you something like the box plot with it, but this one will be in the it's like a plot of it, horizontal plot of it against, let's say, control group, to plot the control group among themselves, plot the treatment 1 on its own and then treatment 2 on its own. But dot chart will display all of them. Okay. So what do we do now? We want to get a dot chart. So we say dot chart, and our X is going to be the data that we are dealing with, which is the numeric one, which is the weight, right? Weight of the, so X is plant growth, and then we select what? Weight. Okay. All right. Now labels here, I will select what? plant growth and its what group. So plant weight and group. Okay. What else do I need? Maybe the plotting character, or here I want it to be horizontal, so I can say my S lab. I want to say it is what weight, just like the weight. Okay. And plotting character, maybe I want to use 2. Okay. And so for let's see how this will look like. So this is what we call the dot chart, right? And it can be anything. Like the plotting character can be anything, or it can be 1, so that you have those points. Like by default, you have those circles, and so this is a dot chart, and you see you have your treatment 2, treatment 1, and then the control, and each of them displayed. And then down here you have your S lab, which is what weight and so forth. You can color if you want. You can color them if you want to, let's say 2 red, and you get all of it as that and so forth. Okay. You can even specify and be able to, let each particular group attain what a different color and so forth. So that's the dot charts and so forth. As I said, you can also try and do this with a strip chart. If you use a strip chart, it's going to plot all this. So you have only treatment 2, and then this will follow like on a horizontal line. Or you can also make it vertical. So you have just treatment 1 on a vertical line to plot it among themselves. Treatment 2 on a vertical line, control on a vertical line. So it's just like what you get a box plot, 2 box plot for such graph. Okay, so I think that should be enough for quantitative data, and that ends our discussion on plot on quantitative data. Okay. Yeah, because I said there are so many. I think, I don't know, let me just add one more, which is like curve, which will help you for those of you who will be dealing with curve sketching. And I'm just going to talk about just briefly, because this is really not part of our, although it helps, but it mainly curve sketching. You can sketch any curve in R, right? From normal 2 by 2, or 2-dimensional, or 3-dimensional, and so forth. Okay, I'm going to talk about just 2-dimensional. Now, what we use in doing that is called curve, right? The function is curve. Okay, so curve. And usually you have an expression, and you have from and to. I'm going to use just that to do this. Okay. Now, so let me say I have a function, and that function is a quadratic function. Okay. So in now, I can denote a function. Let me say that is my function 1, and I'm going to talk about function later on. So this is a prelude to our discussion on function. Okay. So let's say I have a quadratic function which is 3x squared. That's how you will write 3x squared. Let's say minus 2x, 2 times x, and then plus, let's say 3. So this is a quadratic function. Okay. And I can do this as that. Okay. Now, if I want to draw this curve, I can. Or what I will use is your curve. Okay. So curve, and then my expression, okay, my expression is equal to the fun 1. Okay. Then from, where do I want to start from? Maybe from negative 10, okay, up to what? 2, and maybe up to positive 10. So I want to see this expression, this curve, sorry, plotted from negative 10 to 10. And that is it. So this is how it looks like. And that's all what we know about quadratic function. Okay. You can do more about this. Okay. You can, for example, add the y lab, it's fun one, it's not good. But if I want to change it, I can change it, okay, to the formula, and I can use B code, right? B code, and then I put this there, okay? B code this, I will say f of x equals this, and this will write my function right there. I'm sorry, I don't need the equal to in, but if I have to do that, I might use the, yeah, so there it is, okay. So it writes the function, and this we can write any statistical function, okay. We can use expression or be equal to, for example, write the normal distribution function and so forth. So we'll come to this later on in some of our examples that we will do. So I think I can end my discussion on plot here. Thank you.